In this problem, we have a piecewise function, so there are two parts to it, and a constant c. So that just means a number. We want to find out what value should we put in for that number to make this function continuous everywhere. So the function we're looking at is a polynomial in both of its pieces. We need those to match up or stitch together correctly at the point where they come together. In other words, at x is equal to 2, we need these two functions to match up so that we can draw the line of the function without lifting our pencils from the page. In particular, what we need is we need the limit as x goes to 2 from the right-hand side of our function to be same thing as if we just punched in the number 2, to be the same thing as if we came in from the left-hand side of our function. So that's actually the definition of continuous at 2. That is what we are looking for. So we're going to break this up into 2 bits. First bit is going to be coming in from the right-hand side, so numbers that are slightly bigger than 2, which means we're going to be looking at the first part of our function there. So let's actually write that out. The limit as x goes to 2 from the right of f of x is going to be the top part of our step function here. In this case, it's cx squared plus 2x. And we can just punch in our number 2, see what happens. 2 squared plus 2 times 2. So this is going to give us 2 times 2 is 4. I'm going to put that in front of the c. 4c plus c. So this is from the right-hand side of our function. We also need the limit as x goes to 2 from the left-hand side of our function. So this is the same thing as the limit as x goes to 2. We're going to look at numbers that are slightly smaller than 2, but getting closer. So this is going to be the bottom part of our piecewise function, which gives us x cubed minus cx. So now we punch in our numbers there. We're going to get 2 cubed minus c times 2. In other words, 8 minus, and again, I'm going to put the 2 in front of our c. So we have 2 pieces of information that we get from this, right? And both of our solutions have a c in there. What we need to do is set those equal to each other and solve for that variable c. So we're going to do that right here. We have our 4c plus 4, and we're setting it equal to c8 minus 2c. So let's add 2c to both sides. That'll give us 6c plus 4 is equal to 8. We can subtract 4 from both sides. 6c is equal to 4. And let's divide out both sides by 6. So this is going to give us c is equal to 4 divided by 6. In other words, the value that is going to work to make those 2 polynomials come together at the same place is going to be 2/3. Thanks for listening.